Here's an example of a synthesis question involving an organometallic. Some notes on the instructions. We're told that we're preparing our molecule from propene and that all of the carbons in the product must come from propene. What this means, of course, if we have a product that's larger than the starting material molecule, is that we need multiple, more than one equivalent of the propene to start with. We can use any other reagents we want to, but that all of the carbons in the product have to originate from one or more molecules of propene. Pause the video here and see what you can do. One key exercise in this example is to recognize that we're starting with starting material that has 3 carbons, and we're making a product that has a total of 6. So one thing that we need to do is find, and since all of the carbons have to come from the same starting material, we want to find how we break that product into a pair of 3 carbon pieces. That helps us identify what has to be our new carbon-carbon bond, which has to be formed using an organometallic and will be the point of our connection here. And in fact, that can allow us to decide how we make that bond. We identify the 2 carbons that need to be connected. We can put a square around one, a circle around the other, and we could start with the carbon-carbon bond forming reaction. And we can imagine the combination of an organometallic and an electrophile that would produce that particular molecule as a product. Now, the molecule has no functional groups present, and so ideally we're using an alkyl halide, since that will allow us to produce that carbon-carbon double bond without an alcohol group present. If we use a carbonyl instead of an alkyl halide, then we're going to have an alcohol group, which we could get rid of, but that would simply take us extra steps. So at this stage, which side would we want to have be the one with the leaving group? Remember that our leaving group, unless we're using a cuprate, needs to be primary or methyl, and so the first, or the molecule here at the bottom, would be the ideal candidate for that. That means that we would want our top molecule to be an organometallic of some type. We could say a Grignard reagent. And we could use any of the others, really, in this case, except the alkyne anion, which we can't use simply because we can't involve a triple bond in that carbon that is also bonded to 2 other carbons. Then what we need to do is figure out how to convert propene, our starting material, into each of these. So we recognize that to add the bromine at the end, we're doing the anti-Markovnikov addition of HBr to an alkene. Then that's all we need to do from propene. To make the Grignard reagent, we need to remember that the way to do that is from using magnesium and an alkyl halide. We chose the bromide arbitrarily, so we'll use the bromine in the example. And to make isopropyl bromide from propene, we would use HBr in the absence of a radical initiator.